Good morning. Let us see today concentration cells. What are called concentration cells? What are the types of concentration cells? There are two types. For example, electrolyte concentration cell, electrode concentration cell, and liquid junction potential. It is very important how the liquid junction potential is calculated. Okay. Now, what are called concentration cells? They are nothing but concentration cells are nothing but electrochemical cells in which EMF is produced due to the difference in the concentration of either electrolyte or electrode materials. Okay. So what are concentration cells? They are nothing but electrochemical cells in which EMF is produced due to the difference in the concentration of electrolyte or electrode material. For example, hydrogen gas. Hydrogen gas is used as electrode, different partial pressures. Okay, now the types of, there are two types, electrolyte concentration cells and electrode concentration cell, and within electrolyte concentration cell there are two types, remember, without transference, without transport of ions from this oxide to this oxide, and with transference. First let us see without transference. For example, zinc electrode is immersed in zinc zinc sulfate electrolytic solution of concentration or activity A1, and it consists of this cell consists of two electrodes of same metal, same metal, and they are dipped in different concentrations of electrolytes, different concentrations. Zinc sulfate of different concentration, zinc sulfate of different concentration. Okay, and they are connected by salt bridge. Salt bridge is used to connect the two half cells. Okay, it prevents the transport of ions from one half cell to another half cell. It prevents the mixing of electrolytes. Therefore, without transference, the EMF obtained is called without transference. Okay. Let us recollect the electrochemistry we have studied. Please watch the lesson electrochemistry. Left hand Nernst equation, how the Nernst equation is derived. Okay. At left hand electrode oxidation takes place. At right hand electrode reduction takes place. You remember. Okay, zinc is oxidized to zinc 2 plus and its concentration A plus, activity 1 and 2 electron. In the right hand electrode, zinc 2 plus accepts the 2 electron and gets reduced to zinc. Okay, therefore you can cancel 2 electron and zinc metal. Therefore the net overall cell reaction is zinc 2 plus A plus 2 gives zinc 2 plus activity 1. Applying according to Nernst equation, E equal to E0 minus 0.0591 divided by N, number of electrons is 2 here, log A plus 1, product divided by activity of 2. For same electrode, E right minus E left equal to 0. Okay, E0 equal to 0 for same electrode under similar under standard condition. Therefore, this is equal to 0, then you minus sign is there, you interchange. Therefore, the EMF of the electrolyte concentration cell produced is equal to 0.0591 divided by 2 or N log A plus invert A plus activity of this and divided by this. Okay. Now, general formula 0.0591 divided by N log A2 by A1. Okay. Now, let us consider electrode concentration cell. Electrode concentration cell, for example, platinum hydrogen electrode. This is electrode. There are two platinum hydrogen electrodes of different partial pressures. Of hydrogen used. I have shown here. This is platinum electrode. Hydrogen is passed. This is partial pressure P1, and another platinum electrode. Hydrogen is passed to P2, is the P2 atmosphere. Therefore, the electrode, there is a difference in the concentration of electrode, that is hydrogen partial pressures. Hydrogen different in the partial pressures of hydrogen, the electrode material. And therefore, there is another possibility. Now you fix the hydrogen 1 atmosphere. Okay, here the two platinum electrodes of different partial pressures of hydrogen are dipped in the same HCl. Here. Okay, same HCl, because there is only difference in the concentration of electrode. There is no difference in the concentration of the electrolyte concentration is same. Okay. Now there is another possibility. Platinum hydrogen, you fix this. Okay, 1 atmosphere. You fix this 1 atmosphere, and here I have shown, and they are dipped in the same. They are dipped in two different HCl of different concentration. Two different HCl. Platinum hydrogen dipped in HCl of A1, and this platinum hydrogen electrode dipped in HCl of A2 activity, A2 or C2 concentration. Now let us see this one. Okay, this double arrow, double line represents the salt bridge. Okay, in the left hand electrode, as I said earlier, in the left hand electrode, hydrogen is oxidized. Okay, to give 2H plus 2 electron. In the right hand electrode, reduction 2H plus 2 electron is H2 P2. Partial pressure P1, this is partial pressure P2, right hand electrode. Therefore, since H plus is same here, this is for this, H plus is same, therefore you can cancel it, 2 electrons get cancelled. The net overall reaction is this, therefore applying Nernst equation, E equal to E0 minus 0.0 number of electron to log P2 by P1, product by divided by. Since the two electrodes are same under similar condition, it will be 0, E right minus E left. Therefore, this is equal to 0, E equal to, then minus sign is there, so interchange 0.0591 to log P1 by P2. Okay, here A2 by A1, here it will be P1 by P2, you remember. Okay, and next, see this, you have salt bridge here. There is no transport of ions. You have salt bridge, there is no transport of ions. Here, I am talking about this without transference. There is another type. In the case of electrolyte concentration cell, with the transference, there is no salt bridge. Therefore, there will be, for example, I have shown here platinum hydrogen electrode dipped in HCl, different HCl concentration. Therefore, the two solutions are in direct contact with each other. Two electrolytic solutions of different concentrations are direct contact with each other. Therefore, at the liquid junction, there is a potential developed due to the concentration gradient. Diffusion of ions across the membrane, which allows only ions to pass through. So the two electrolytic solutions of different concentration are in contact with each other because of the transport of ions from here to here. Okay, now the EMF of the cell, EMF of the electrolyte concentration cell, including transport number. What is transport number? It is the fraction of the current carried by the ion. Therefore, the formula is same thing, 0.0591 log A2 by A1, here A2 by A1, and here 1, this is P minus transport number of anion, Cl minus, and this is the transport number of cation. The sum of the transport number is equal to 1. Okay. So therefore, this is without 0.0591, and here as you see, this is here, this case H plus transference of HCl from here. Okay, HCl, H plus same A activity, and T transference, because here there is no transference, here there is transference. Therefore, the formula used is T minus, and here the oxidation is 1 by 2 H plus, 1 by 2 H2, sorry, 1 by 2 H2 gives H plus 1 electron. In the right hand electrode, it is 1 H plus 1 electron. Therefore, only 1 electron is involved. Okay, in this concentration cell. Therefore, without transport And how the liquid junction potential is calculated? It cannot be measured directly. It can be obtained from subtracting E with the transference minus E without transference. You will get the liquid junction potential. Therefore, on subtracting this, T minus 1, okay, 0.0591 divided by 1 log A2 by A1. So these are very important for IIT JAM as well as GATE CSIR. There are several problems asked on this and also useful for NEET, etc. Okay, thank you for watching.